Hello class, today we are going to talk about angles. Angles, that's right, everybody's seen angles, but that's okay, we're going to define them anyways, just in case you don't remember what they are and you don't remember just by looking at my thing here. So, definition of an angle, what this is a shape that is formed, by two rays with the same endpoint. So two rays with the same endpoint. With the same endpoint. That is two rays with the same endpoint. All right. So let's take a look at this angle I've got over here. All right, we'll start with this one. So here I have an angle. It is formed by two rays. All right. We have one ray, we have two rays, and when they come together, they form an angle. Right there. Now this point here, that common end point, that is called the vertex. So in this, the vertex is the point B. And the rays themselves, those are called the sides of the angles. So my sides, I have ray BA and I have ray BC. Those are the sides of the angle. Okay. Now the question is, how do we name this angle? Now we've got to be able to name it so I know we're talking about this angle, not some other angle, right? So when we name an angle, we are going to use a symbol because we like symbols. This symbol here that looks like an angle, that's read as angle. And it doesn't matter how wide the angle is, doesn't matter what direction the angle is facing. We will always use this symbol like this, so it looks like kind of like an L that's leaning over a bit. It's always going to look the same for the symbol, okay? So we have angle, and one thing we can name this, well, we notice there is a nice little 1 inside the angle, so I could name this angle 1, just like that. If you have a number inside the angle right there next to the vertex, you can name the angle by that number. So angle 1. Other thing we could name this, I could name this angle ABC. This is very much like when we named polygons in the previous video. You start at one point and then you go around the angle. So ABC. We could just as easily start at the other point there on the side. We could call this CBA. What you cannot do is call this angle BAC. Again, you can go around the lake in either direction you want. You can't jump across the lake. Okay? So what this means is that every time you name the angle by the points on the angle, you have to have right here in the middle the vertex. The vertex will always be that middle letter. Vertex, right there. And any angle you have, pretty much, you can always name it like this. You can always name it by a point on one side of the angle, the vertex, and a point on the other side of the angle. Now there are special times, special cases, where we could also call this angle B, just naming it by the vertex. And for that to happen, it has to be the only angle that has B as a vertex. So if I had had another ray coming out here, we couldn't do that, because then we're like, okay, you talk about angle B for this angle, angle B for this other angle. Which angle are you talking about, right? And you'll see that better over here in this example, right here. See, I have X is the vertex, but it's the vertex for angle 3. It's also the vertex for angle 4. So if I just say angle X, yeah, which angle are you talking about? Just like if I say Mr. Smith. Well, which Mr. Smith are you talking about? There's a bunch of them, right? So you got to be more specific. And so what we'd have to do is name it by the points on the sides as well. Okay, now, angles do have different parts, okay? You have different parts of an angle. So really quickly, flip back over here. You have the interior of the angle, that is right here, in between the two rays. This is the interior. And you have the exterior. Exterior is the stuff outside the rays. So this is exterior. And this down here is also exterior. All right. All of that is exterior to the angle. Now the question, what about A and B? What about point A and B and C? Those points. Those points are on the angle. They're not inside the angle. They're not outside the angle. They are on the angle. All right? Okay. So what I'd like you to do is pause the video and answer these 3 questions here. Then come back. All right. So you pause the video. You're back. And the first question is, blank is in the interior of blank. And there's actually a lot of things you could put here. First, let's pick an angle. All right, so we could say that U, point U, is on the interior of angle 3. Right, because we've got angle 3 there, and U is inside angle 3. That would work. You could say that U was inside angle WXY. That would work, because U is inside the whole big angle there, right? What about Z? Is Z interior to anything? Well, yeah, we could say that point Z was interior of angle WXY, or angle YXW, whichever way you want to call it. All right? But do we have any points interior of angle 4? No, we have nothing inside angle 4 that is labeled, so we couldn't use angle 4 here. All right? Now, it wants a name for angle 3, obviously wants a name for angle 3 other than angle 3. So if you put angle 3, no, that's not good. We need something else. So, could we call it angle X? No, there's too many angle X's here. We can't call it angle X. It's got to be more specific. So, what we're going to do is we are going to use the points on the side. And so we'll call this angle ZXW, or we could call it WXZ. Either way is good. As long as you have a point on one side of the angle, you have the vertex, and then you have a point on the other side of the angle coming around the angle. Okay? So the name for angle 4, you could call it either angle ZXY, or you could call it angle YXZ. That would be fine. You cannot call it angle Z because there is another angle Z there. There are actually 3 angles Z. We have 3, 4, and then angle WXY. All right, so we have 3 angle Z's. Can't call it angle Z because there's more than one angle Z. All right. Next thing we're going to talk about how to classify angles. And angles can be classified a couple of ways, but what we're going to do, we're going to classify them by their degrees. How wide is the angle? So first we have acute angles, and hopefully you'll remember all of these from previous years. So we'll say this is angle A. This is an acute angle, all right? And the definition of an acute angle is this has an angle that has a measure of less than 90 degrees. So it measures less than 90 degrees. Less than 90 degrees, but it still has to be more, so, and more than 0 degrees. More than 0 degrees. Okay, so let's put this in symbols because we like symbols, because we do math. So what we have here, 0 is less than, not less than equal to, less than the measure of angle A, which is less than 90 degrees. 0 degrees is less than the measure of angle A, which is less than 90 degrees. All right? It's got to be in between. And I have a protractor here so we can look at that. I can kind of show you. It won't be great because I didn't draw that very straight. Should have used a straight edge. Anyways, so remember, to use a protractor, we have the center of the protractor right there. We match that up with the vertex. We match one of the rays with one of the zeros. I've got a 0 here and I've got a 0 there. So it doesn't matter which way your angle is facing. You can use it either way. And then since the 0 is on the inside track, I'm going to use the inside track and find that other ray right there and see some of this angle is about 32 degrees. It doesn't bother this so hard, which is clearly less than 90 degrees. So it's acute. All right. Let's do another one. Obtuse. All right. Obtuse angle. Obtuse angle. That looks something along these lines. All right, we'll call this one angle B. Okay. An obtuse angle, definition, this is an angle that measures more than 90 degrees. All right. Measures more than 90 degrees. More than 90 degrees. And it also has to be less than 180. Less than 180. Less than 180. So, again, symbols, because symbols are fun. 90 degrees is less than the measure of angle B, which is less than 180 degrees. All right? And notice here when I'm talking about the degrees, I'm putting a little M before it. That's measure of angle A, measure of angle B. Just like we have a different symbol when we're talking about the length of a segment. All right? This shows we're talking about that number that is the measure of angle B. How wide is it? All right? And as you see, I'll pull up my protractor here. We center there on the vertex. We match one array up with 0. This time 0 is on the outside track. And so I come around here to find that other ray, which is right there. And on the outside track, it is pointing at about 149. Right? Clearly more than 90 degrees. All right. So that brings us to the straight angle. And a straight angle, actually I'm going to use a straight edge for this one since it is called a straight angle. That should be appropriate. A straight angle, very simply, is going to be something that looks a lot like this. There it is. Angle C. Or we can make this a little bit. We'll call this DC. There we go. Here, we have a straight angle. And a straight angle measures exactly 180. Measures exactly 180 degrees. Exactly 180 degrees. So, the measure of angle DCE equals 180 degrees. Another thing about straight angles, the reason they're called straight angles, is they form a straight line. Form a straight line. Straight line. Now we said it had to be made up of 2 rays, right? That was our definition. Formed by 2 rays with the same endpoint, which means I have 2 rays with the same endpoint. This is also opposite rays. Opposite rays form a straight angle. Right? Okay, so we have one left, and that is the right angle. We deal with this a lot. So a right angle is this right here. This is a right angle. And a right angle measures exactly 90 degrees. Measures 90 degrees. Exactly. And so we will call this angle F. So the measure of angle F equals 90 degrees. And when we have a right angle, we actually have a special symbol for that we put right there in the graph, and that in the diagram is this little box. And what that is, it means it's perpendicular, it means it's 90 degrees. That way, if I hold my protractor up to it and I didn't draw it exactly right, it's okay because I've got the box there which says, hey, it's 90 degrees, even though the protractor says it's 88. That's fine. Now, this is a right angle. What's a left angle? Yeah, it's a trick question. There's no such thing. Okay? Doesn't matter if it looks like this or if it looks like this. It's still a right angle. Even if it looks like this, it is still a right angle. There is no such thing as a left angle. All right? So real quickly, let's see. We needed to classify angle B earlier. We didn't do that. So let's do that now. So looking at angle B, is it going to be acute, obtuse, straight, or right? Yeah, that's easy. This is acute. It is quite clearly less than 90 degrees. So this is acute. It's a cute little angle. So cute. All right, now, what I want you to do, I want you to pause the video and answer these 4 questions here. I want you to A, name the angle. Angle X, angle Y, angle JKL, whatever. Tell whether the measure is greater than 90, less than 90, greater than 90, equal to 90, or equal to 180, and then classify the angle. So pause the video and do those 4 real quick. All right, let's see how you did. So first we're going to name the angle. All right. So the angle, I've got to name it by the vertex, which that's right there, the number in the middle, so I could call this angle Y. I could also call this angle XYZ. I could call this angle ZYX. Any of those is good. And this angle, we want the measure, so the measure of angle Y is, well, that's a straight line. So this equals 180 degrees, and it is a straight angle. Straight angle. All right, let's take a look at the next one, number 2. We have to name the angle. So I could name this angle FPY. One side, vertex, other side, right? I could also call this angle P, because that's the only angle there. And so the measure of angle P is equal to, not equal to, I don't know exactly what it is, but it is clearly smaller than a right angle, so we are going to say that this is less than 90 degrees. And since it's less than 90 degrees, that makes it acute angle. Acute. All right, next one we have down here, we have angle CTL. CTL, or since it's the only angle there, you could call it angle C. And the measure of angle CTL, well, this one, it's got the little box right there in the middle, so that means this exactly equals 90 degrees, and it is a right angle. All right, last one we have on this, angle U. Or we could also call this angle SUN. We'll do that. Angle SUN, or we could call it angle U. We could call it angle NUS, whichever. And so the measure of angle SUN is, I don't know. It's not a straight line. It's not a right angle. And so we look at it and we see that it is bigger than a right angle. So this is going to be greater than 90 degrees. And so this is obtuse. Obtuse. Okay, and that's the basics of angles, but there are 2 other things that we want to talk about. And that is angle addition postulate and the angle bisector. Now, the angle addition postulate, this is basically the same thing as the segment addition postulate that we talked about earlier, except we're talking about angles. All right. And what this says, definition, if K is in the interior of angle HIJ, then the measure of angle HIK plus the measure of angle KIJ equals the measure of angle HIJ. That's lovely. All right, what that means, if K is inside, so we've got these two angles that are next to each other, right? And they're next to each other, we call those adjacent angles. So if these two are next to each other, they have the same vertex, then the measure of angle HIJ, the whole big thing, is equal to the measure of the little one plus the measure of the other little ones. That's what this means, okay? Which makes sense. You have this piece plus that piece, it gives you the whole thing, right? Okay, so let's take a look at an example over here because it makes more sense when we have examples. So if the measure of angle AOC equals 70, so that's the whole thing, AOC, the whole big thing is 70, and the measure of angle AOB, so AOB, so this little piece right here is 1/2 2x plus 20. Let's do this. So this is 1/2 times 2x plus 20. Always nicer degrees. Always nicer to put it on the picture, right? And the measure of angle BOC, so BOC, this little angle, is equal to x degrees, so x degrees. We need to find x first, okay? So, well, we don't know. Are these two equal to each other? No, they're not equal to each other. What they are is that they are parts of the whole big angle, and we know the whole big angle to be 70. So, the way I'm going to set this up, I have 70, the whole big angle, equals AOB, right? So, actually, I'm going to write it like that. The measure of angle AOB plus the measure of angle BOC. And then we're going to plug it in. So 70 equals 1/2 2x plus 20 plus x. All right, so let's solve this. First thing we need to do, we need to distribute in that 1/2, right? So 70 equals, well, 1/2 times 2x is going to be 1x. 1/2 times 20 is going to be 10, and then just drop that down, plus x. Alrighty, so now we can, let's go ahead and move the 10 over, get all these x's by themselves. So minus 10, and so I have 60 equals 2x, right? X plus x. So if 60 equals 2x, I can divide by 2, and x equals 30. There it is. So x equals 30. So now let's see, I need to find the measure of angle BOC. BOC was x. Well, I know x equals 30, so 30. And I now need the measure of angle AOB. Now here you have two options. Option number 1, you can take this and plug in 30 for x. 1/2 times 2 times 30 plus 20. Okay, so 2 times 30 is 60, plus 20 is 80, so 1/2 of 80, which is 40. Or option 2, I know that 70 equals AOB plus BOC. So 70 equals the measure of angle AOB plus BOC, which is 30. Subtract 30 from both sides, and I end up with the measure of angle AOB equals 40. Same thing we had there. And it also checks to make sure you did it right. Angle addition. Not too bad. This piece plus that piece equals the whole thing. Okay, one last thing we got is the angle bisector. And this basically is just like the segment bisector, only with angles instead of with segments. All right, this is a ray that divides an angle into two congruent angles. So if XZ is an angle bisector, then it means that WXZ is congruent to ZXY. All right, and the way we show congruent angles is with these little arcs like that. Okay. This right there means congruent. means congruent. Okay? Just like those tick marks on segments. With angles, we use arcs. All right. So let's take a look at this example. Ray FG bisects angle EFH. Okay, so FG is this one. It bisects angle EFH. Okay. If the measure of angle GFH, so GFH, this one right here, is 1/2 10x minus 20. Let's go ahead and put that down here. 1/2 10x minus 20 degrees. And the measure of angle EFG, so EFG, this one here, is 3x plus 25. 3x plus 25. And we put it in parentheses here and put a degrees there to show that this is degrees. Okay? So the parentheses here aren't really doing anything. But then we want to find all this stuff. All right, all that stuff. So what can we do with that? Well, we know that FG is the bisector, which means that these two are congruent, which means this must equal that. So let's set them up that way. 3x plus 25 equals 1/2 times 10x minus 20. All right. First thing we want to do here is probably distribute that 1/2 in there, because that's going to cut these down pretty small. So 3x plus 25 equals 1/2 of 10x would be 5x, and 1/2 of negative 20 would be negative 10. There it is. Now we want to get all of our x's together, because that does make it easier, right? So let's move the 3x over. Minus 3x, minus 3x. This is getting a little bit. So that gives me 25 equals 2x minus 10. Now we want to move the 10, so we have x by itself, so plus 10, right, right. And we end up with 2x equals 15. Yeah. So we now have 2x equals 15. And we want to get x by itself, so we divide by 2, and now x equals 15 halves, or if you prefer, 7.5, whichever. 15 halves, 7.5, whichever one you like. This 7.5. Okay, now we need to find GFH. So we're going to take this and we're going to plug it in right there. So let's do this. Let's get some other numbers, other colors here. So GFH, we have measure of angle GFH equals 1/2 times 10 times 7.5 minus 20. Alrighty. So 1/2. Well, 10 times 7.5. Well, I can multiply by 10. That's not too bad. I just move the decimal over, right? So that's 75. 75 minus 20 would be 55. And so the measure of angle GFH equals, let's see, 55 halves, half of 55, that would be what? 2 goes into 5 twice with 1 left over, so that's 15. 2 goes into 15 7 times with 1, and so 7.5. And this is a measure of an angle, so that would be degrees. So 27.5 degrees, like so. Now we need the measure of EFG. Now I could take this 7.5 and plug it in right there for that x. However, I know it's bisected, so I know those two equal each other, don't they? Yeah, they do. And so EFG is going to be also 27.5 0.5. I don't even have to work it out because I know they are congruent, because it was bisected. All right, next thing, EFH. That's the two of them added together. When we add them together, let's see here. 5 plus 5 is, that'll be 0.0. Carry the 1, so that's 14 plus 1 is 5. 14 carry the 1, and so 55.0 degrees. Because they're the same. There they are. All right, and our last one is IFE. IFE. Now, this one is a little bit trickier. What we have to do here is we look at angle IFH. Notice IFH is a straight angle, right? Which means, since angle IFH is a straight angle, then that is 180 degrees, right? So what we can do is 180 degrees equals the measure of angle EFH plus the measure of angle IFE. So that's going to equal 55 plus the measure of angle IFE. And, of course, all we have to do there is subtract 55 from both sides, minus 55, minus 55. And so the measure of angle IFE equals, let's see here, so that would be 5, oh, that says 5, 7 minus 5 is 2, and that is 125. 125 degrees. All right. And there it is. That is angles. All right. Angles are classified by their degrees. How wide is the angle? They are named by the points on the angle, a number inside the angle, and if it is the only angle, by the vertex. If there's more than one angle there, not by the vertex. We couldn't call this angle F because there's lots of angle Fs. All right. Angle addition postulate. If two angles are side by side and they have the same vertex, then you can add their measures up to get the measure of the entire angle. And angle bisector is a ray that bisects an angle. It cuts it into two congruent pieces, cuts it perfectly in half. And there it is. Hopefully y'all found that useful, and I will see you in the next video.